G'day, Standard Mathematics students. Thank you so much for clicking on this video. Today we're starting a new series of revision videos looking at specific topics in the course and going through a number of questions across all different bands, and just to sort of give you a refresh of the topic and help you build some confidence going into your HSC exam. So today's first band boosters video is starting with the Year 11 topic of perimeter area and volume. Because it's a topic that I really enjoy, and it's a topic that has always got some questions in HSC, so it's worth doing some practice with. Just to clarify before we begin, when I'm talking about bands, here are a reminder of the HSC bands for standard maths. So for example, we're about to look at a band 2 question. This means that students who got this question correct typically scored 50 or above. Okay, so it doesn't mean they only got the 50s, it means they got above 50 typically. So when we eventually get to the band 5 question, students who were getting the band 5 question correct were typically getting the marks in the 80s or above. Okay? All right, so let's start off with the band 2. This is the easiest question we are looking at today. It's a 1-mark question from the 2016 HSC paper. Calculate the surface area of a sphere with a radius of 5 centimeters, correct to the nearest whole number. Alright, sweet. So to get the most value out of this video, I always recommend that you pause the video after I've read the question and you have a go yourself, because once you've had a go, hopefully get it correct. And if you get stuck, then the solution will make more sense to you once you've had a go and will have more impact on your revision. Okay, so if you have a formula sheet handy, potentially worth looking up the surface area section of your reference sheet. They only give you 2 formulas, and you need to know that this first one is the surface area of a closed cylinder, and the second one is the surface area of a sphere. So all we need to do is 4 times pi times radius squared. And so as long as you know which formula you're looking for, you're going to get this question correct, which is why it's a band 2 question. So really, really important that you're familiar with everything on that reference sheet so you can pick up some free marks like this question. So there's our magic formula. We're going to be doing 4 times pi times 5 squared. Putting that through the calculator, we get about 314 point bloody blah. Question wanted nearest whole number, so we'll say about 314 square centimeters for your correct 1 mark. All right, that was the easy warm-up stretch. Now let's look at the band 3 question. So students who are getting this question right scored 60 or above, typically. All right, this is adapted from the 2018 HSC paper. It's not the exact question because in 2018 in the old syllabus, they didn't use trapezoidal rule, but it's pretty similar. So it's a 3-mark question. We've got a field bordered on one side by a straight road, we can see here, and the other side is bordering a river. Measurements are taken perpendicular to the road every 7.5 meters. Use 4 applications of the trapezoidal rule to find an approximation to the area of the field. Okay, so trapezoidal rule, if you're a bit forgetful, once again, the reference sheet has got your back on this one. It actually gives you the area of a trapezium twice for some reason. So the top one is the area of a trapezium and the bottom one is the trapezoidal rule, but you're essentially doing the exact same thing. So if you know you're using this formula, it makes the question a lot easier. So now we're going to do some calculations. So the trapezoidal rule basically says that these 4 areas, because of their curved boundary, are a bit too complex to calculate accurately. So what we're going to do is we're going to take a dodgy shortcut and we're going to turn these into 4 trapeziums. We're going to find the area of the 4 trapeziums and add them together, and we'll say that's our approximation. It's not exact, but it'll be close enough for us. So for the area of a trapezium, all you need is your A and your B, which are your 2 parallel or flat sides. So in this first trapezium here, A is going to be 8.8 and B is going to be 7.1. H is just how far apart your 2 flat edges are. So H is going to be 7.5 for all 4 of these trapeziums. So here's our first one, our height of 7.5 divided by 2 multiplied by 8.8 and 7.1 plus together. So there's trapezium 1. Here's the next one. The height should always be the same for all your trapeziums when you're using the trapezoidal rule. So we've got 7.1, 9.8. Here is the third one, 9.8, 8.5. And the last one has 8.5 and 4.9. So now the challenge is to put this into your calculator without stuffing up a number or putting a decimal point in the wrong place. If you put it through correctly, you should get an answer of around 241.875 meters squared. The question didn't specify any rounding, so you can leave your answer in any form you want. I'm just going to leave mine as 241.875 meters squared. Okay, cool. If you got the same thing, you would have got 3 marks in a Band 3 HSC question. Let's go and look at the next one. This one is from the 2018 HSC paper. It's a 1 mark question because it was a multiple choice question, but I've cut off the answers to make it a bit more interesting. We've got a shape consisting of a quadrant, which is a quarter of a circle, and a right angled triangle as shown below. What is the perimeter of the shape? Correct to 1 decimal place. Pause and have a go if you're in the mood for it. Okay, so to find the perimeter of this shape, we're trying to find the distance around the outside. We have the 6 and the 10, so all we really need is this distance here, which I'm going to call R. And the marking says that if this is R, then so is that, because it's the radius of the quarter circle. We also need this curved piece here, which I'm going to call L for now. L represents length of an arc. Okay, so looking at this diagram, how can we figure out R or L? I'll give you a hint that finding R first is a good call. Let's look at this triangle here. The question mentioned very specifically, it is a right angled triangle. So how can we use the fact that this is a right angled triangle to find the length of R? If you were paying attention in year 8, you would have learned about Pythagoras' theorem, and we can use it here. We know that the 2 shorter sides squared and plus together is equal to the hypotenuse squared. So we know 6 squared plus R squared is equal to 10 squared. We can rearrange this to subtract. So we're going to do 10 squared take away 6 squared. So we're solving the equation for R squared. On the right, we get 100 take away 36, so we get 64. And so the square root of 64 is now 8. So the length here for the radius is 8. So we can replace those with 8s. Now we need to find this length here, which, like I mentioned before, is the arc length. It's a quarter of the circumference of the circle. So imagine this was a whole big circle. We're trying to find a quarter of the circumference. Okay, which is kind of tricky because the formula for the circumference is not on your formula sheet. There's a formula for arc length, which could be useful here. But we're going to approach this as saying L is a quarter of the circumference. So as long as we know that the circumference is calculated by 2 pi r, we can multiply that by a quarter and then we'll have our distance L, which is great. So pi is just pi, r we just found, that's the value here, the radius is 8. So we're going to calculate 1 quarter times 2 times pi times 8. That works out to be around 12.6. I rounded to 1 decimal place because the question said our final answer for the perimeter should be 1 decimal place, so that's all good. Okay, now we have all we need. We have the 8 here, we have that length L here is 12.6. So we'll finish off and find the perimeter by adding all the 4 sides together. So we're doing the 10 plus 6 plus 8 plus 12.6. We aren't going to include this 8 here because it's not on the outside of the shape, so you're only counting the exterior edges. All right, we get a final answer of 36.6, which was one of the 4 options in the multiple choice question. Okay, there's band 4 done. Let's get on to the really, really challenging ones now, starting with the band 5 question. This one, once again, is from 2018. So the last 3 questions have all been from the 2018 HSC paper, which goes to show you that just one topic, one year 11 topic can have multiple questions in HSC. So you've got to cover as much content as you can from both year 12 and year 11. Okay, we have a 3-mark question, a band 5 question. A cylindrical water tank has a radius of 9 meters, we can see right here. And a capacity, so how much water it can hold, is 1.26 megaliters. What is the height of the tank? Give your answer in meters, correct to 2 decimal places. Okay, so what you typically see in band 5, 6 questions is there's a lot more reliance on content knowledge. So the people who are getting the band 5 and 6 questions right are the ones who have studied hard and they know their content. The content that we need to answer this question that isn't given to us is a few things. First of all, we need to know that a megaliter is 1,000 kiloliters. So if we want to translate this 1.26 megaliters, we can times it by 1,000 and we get 1,260 kiloliters. That's important because our content knowledge also tells us that a kiloliter of water is 1 cubic meter of volume. Okay, if you think about in your room, if you had a box that was 1 meter by 1 meter by 1 meter, it'd be pretty big. It could hold 1,000 liters of water. So if our cylinder can hold 1.26 megaliters, it can hold 1,260 kiloliters, which means it's got a volume of 1,260. This is really important because now we can use our volume formula and we can work backwards and we can find the value of H. All right, so we also need to know that the volume formula for a cylinder is pi r squared h. That is not on the reference sheet, unfortunately. It does need to be a part of your content knowledge upstairs in your brain. So this is just the area of the circle, pi r squared, so the area on top, multiplied by the height of the cylinder. Same idea as the volume of a prism, basically. Okay, now we can use this formula. We know the volume in cubic meters is 1,260 because cubic meters and kiloliters are the same thing in terms of space. We know the radius is 9 from the picture and from the question. We obviously have pi as pi, and we're trying to solve for h. So we have 1,260 equals pi times 9 squared times h. Swapping sides over, and we can write pi times 9 squared. We'll write that as 81 pi for now. So we have 81 pi times h is equal to 1,260. We are trying to solve this equation for h, so we need to divide both sides by 81 pi to get rid of it on the left-hand side. So we end up with h equals 1,260 divided by 81 pi. We'll feed that through the Casio, through our calculator, and we'll get an answer around, corrected 2 decimal places, about 4.95 meters. So if we were working forwards and doing trial and error, that would have taken a long time to get it this accurate. So it's always best to rely on your algebra and rely on your content knowledge to work forwards to get a solution. Okay, that was a pretty tough question, but that's not the toughest we're doing today. We're going to do one more challenge question for our Band 6 students. So this one was from the 2017 HSC. It was the very last question in the paper, so that's where they usually put a Band 6 question. We have a solid is made up of a sphere sitting partially inside of a cone. So it's basically like an ice cream cone. The sphere has center O and it's got a radius of 4 and it sits 2 centimeters inside the cone. Solid has a total height of 15 centimeters. The solid and its cross section are shown. Okay, so pretty much everything in that sentence or that paragraph there is shown in the picture here. So we'll get rid of the text because we don't need it anymore. The question was, what is the volume of the cone correct to the nearest cubic centimeter? If you're feeling very brave, you can pause and see if you can figure it out, but there's a lot in this question to figure out on this picture to help you figure out what the volume of the cone is. So we're trying to find the volume of just the cone on the bottom. Okay, cool, here we go. So first thing we need to notice is that the volume formula for a cone is similar to the volume formula for a pyramid. So volume of a pyramid on your reference sheet is 1/3 of the base area times the height. For a cone, your base area is a circle, so that capital A becomes pi r squared because that's the area of a circle. So we need to find two things to find the volume of our cone. We need the radius of the cone and we need the height. So I'm going to mark these with red lines. There's our height and there is our radius. Okay, so let's try and figure these two values out. The one we can figure out from the picture is the red line, which is the height. But we've got to be clever. First thing we've got to think about is this blue line here. What do you reckon the length of that is right there? Or a better question could be, what is the distance from O to the edge of the circle? Edge of the sphere, circle, same thing. Well, we know that full length there is going to be the same thing as the radius, which is 4. So from O to the edge is 4. That little red part there is 2, which means that blue part must also be 2. Because 2 plus 2 is 4. We also need to think about this green line from O, once again, up to the edge of the sphere or the circle, is once again the radius, which is the same thing here. It's anywhere you go around, it's always going to be 4 centimeters. So think about this, the entire thing from top to bottom is 15. This part's 4 and that part's 2. So how much from this part all the way down to the bottom? Well, what's 15 take away 2 take away 4? 15 take away 6 is going to be 9. So there is our height. So that red dotted line there has a value of 9. Okay, sweet. Now we need to figure out the radius, which is the red line just here. Once again, similar to the earlier question, we can see we have a right angled triangle, which is good news because we know how to use Pythagoras. So once again, we're going to use Pythagoras to figure out what the dotted red line here is for the radius. So we're going to call it r for now. Because this is a right angled triangle, we know that r squared plus 2 squared is equal to 4 squared. So we're going to write our Pythagorean equation. A squared plus b squared equals c squared. We are going to solve this for r by once again subtracting. So we'll do r squared is 4 squared take away 2 squared. 16 take away 4 works out to be 12. So we get r squared is 12. So that means that r is going to be the square root of 12. Now we aren't going to put that into our calculator yet because it's going to give us a long decimal. And if you're a band 6 student, you know that you shouldn't be rounding your answer until you're done with the question. So for now, we're going to leave r as the square root of 12, and we're going to use that in our calculations to be as accurate as possible. All right, so we've got root 12 there. Now we have everything we need to find the volume. We've got our formula from our content knowledge and from our formula sheet. We've got our radius, we've got our height, so now we can do some maths. So we're doing volume equals 1/3 times pi times radius, which is root 12 squared, multiplied by the height, which is 9. We'll feed that through the calculator and we get an answer of, to the nearest centimeter, works out to be 113 cubic centimeters. So if you managed to get that by yourself, congratulations, you may just well be a band 6 HSC student, but we'll have to wait and see. All right, if you made it this far, cheers for watching. I'll probably do another one of these next week if I am bored enough and feel like I should. So if you have a suggested topic that you are maybe struggling with in your study and you want some practice questions in a video, by all means, let me hear about it and I'll see what I can do. All right, cheers guys, see you later.